Well, our next topic is JSON, and JSON is part of the larger NoSQL movement. And what some people think of when they think of NoSQL is that they don't want to have a SQL server. They don't want to have a heavy-duty relational engine. And one of the things that's interesting about SQL Server support for what we're going to see is that you can actually think of NoSQL as not only SQL, which is to say you've got your relational data, but you can also have this non-relational data, such as XML that we just talked about, and then some of the other things we're going to look at here. So with that as context, let's talk about JSON. So what is JSON? JSON is the JavaScript object notation, and it's essentially a lightweight data interchange format. And you've thought, well, I've heard this before. That's what XML was called. I don't think anybody's ever called XML lightweight. But the idea here is it's easier to read and write, certainly, than XML. It's language independent, which means you can use any of your .NET languages or other languages to work with it. And if you're familiar with JavaScript, you're already familiar with the syntax for JSON because it uses objects and arrays and values just like you're used to with JavaScript. So the idea here is we can take JSON and store the application data natively in SQL Server instead of, again, passing in strings and having to convert them as we store them and convert them back as we read them out. Now, the way that we would store them in SQL Server is in using the nvarchar data type or using another feature of the SQL Server data platform, which is called DocumentDB, that we'll be looking at in the next topic. So at a very high level, again, our goal here is not so much to teach you all of the details of these, but to place them in context with the data family. Let's take a brief look at JSON objects. The idea is that we're going to identify name and value pairs using colons. So we're stripping away a lot of that extra language of XML with brackets and all of that, and we're simply going to have name colon value. If you're representing an object, you'll wrap that in curly braces. And if you've got multiple sets of name-value pairs, you'll separate them by commas, as you see here on my screen. And what is also nice about this is that these objects can be nested. Let's see what that example that we looked at earlier of selecting last names from our customers table would look like if we're extracting this as JSON. So once again, we've got our last name column from saleslt.customer. Once again, I'm selecting only the top 5. And this time, instead of saying for XML auto, we're going to say for JSON auto, and we'll see that that's now being encoded. That's being passed out to us wrapped in square brackets with then each record or row from the source table being wrapped in curly braces as a name-value pair. So last name G, last name Harris, last name Carreras. And if you're reading this, you're thinking, well, gee, that's a little bit redundant, just like it was in XML. But the idea is that each value stands alone. We can tell what it is while we're looking at it. What's Gates? Gates is a last name. So with JSON, just like we could with XML, we also have some programmatic ways to handle it. So I might declare an nvarchar variable to put JSON data is. And when I do that, I'm going to create a schema using my key and value and type. But I don't necessarily have to strongly type these the way that I would XML or even T-SQL data. This can be assigned when I actually populate it. So I might declare this variable and then use the OpenJSON function to pull whatever values are out of that. So I might have values of nulls or strings or numbers. I can also store Booleans. So the idea here is that if you're already using JSON in an application, or you want to use JSON in your application, you can take advantage of SQL Server and Azure SQL Database to store these.
All right, well, let's take a look at working with JSON then.
Sounds good. Here's a demo.